Hi, I'm Dr. Salim Afshar, the Chief Medical and Innovation Officer here at Reveal HealthTech. And I'll be talking to you today regarding the emerging landscape of AI in healthcare. We're entering the most extraordinary period in technology. AI is everything, everywhere, and all at once. Elon Musk thinks that AI will be the best or worst thing for humanity. I disagree. I don't think it's that dichotomous, but I do think we'll have some growing pains. Now, when we look at the history of AI, there's some important milestones to be noted that have built the foundation of where we are today. George Hinton, in 1986, proposed backpropagation as a new methodology, and that has become the foundation of what we've started to build our tools on. And fundamentally, the attention mechanism in 2015 is what led to the transformer model, which has become the core pillar for all the large language models that we've experienced, including ChatGPT. Now, when we look at artificial intelligence, the goal is to construct a machine that can simulate human intelligence. These are tasks that are associated with intelligence of beings. In this subcategory is machine learning, in which we supervise or have unsupervised learning. And the goal here is around detecting hidden structures. Now, deep learning are algorithms that can learn to recognize patterns in the data. And these methodologies are the core pillars for artificial neural networks, as well as the ability for these networks to learn complex patterns from large data sets. Now, there are three categories of models within artificial intelligence. The first one is the most simplistic, and it's deterministic models. These are algorithms that are fully predictable. You put the same data and same parameters, and you get the same outcomes and predictions. Think of simple linear regression models. The second category is around discriminative models. These models are used in machine learning. These are statistical models that are used to discriminate between different outcomes or classes based on features of the data. The last category are generative models. These are models that are trying to figure out how the data was generated. They try to understand the underlying process. Now, there have been several recent events that have accelerated the artificial intelligence paradigm. One is a shift in models, moving from unimodal to multimodal models. Multimodal models are models that integrate multiple data sources at the same time. So think of text, images, and video, whereas unimodal are working within one of those domains. The second key component that's tied to this, the ability to do multimodal AI models, is the hardware evolution. We've gone from CPUs, which had single core that were very fast for a single task, to multi-core, which are slower per task, but parallel in processing, allowing multiple tasks at the same time, to now GPUs, which are thousands of cores. These cores are all in parallel, so they're able to do a massive amount of parallel workloads. These GPUs are great for specific tasks, such as graphic processing, but they're super slow for serial computing, but very fast for parallel. And this has enabled us to do multimodal models. Now, what is ChatGPT? ChatGPT is a generative model, right, where, again, it tries to understand the underlying process, but specifically around language. And you can categorize it under this large language models, or LLMs. They try to approximate how we talk to each other and how we interact with each other. There are multiple large language models being produced, from Palm 1 and Palm 2 from Google, and to BART, as well as the GPT-4 that's from OpenAI. Now, there's 5 general applications of GPT. The first one is around companionship. You ask yourself, I need a friend or a coach, or I need to learn a language. So a lot of applications are being built using the large language models to enable this category of application. The second category is around question answering. Search the following and tell me the following. So think of a plagiarism tool in which you give it a document and you're asking a specific question. The third is around utility. Do this and tell me what I need to do. So for example, read every WhatsApp message or every email and tell me what I need to do or what the tasks are. Another example is you can say, look at all the guidelines within our hospital and tell me what I need to do in this scenario. The fourth one that's been pretty obvious publicly is around creativity, where we're generating new data. So think of new images, new video or sound, and that's fundamentally what ChatGPT is doing when you log in and you're creating new content. This is also where we've seen evidence of deep fakes that is quite concerning. The fifth category is multi-step task agents. These are bots, basically, that have a specific goal. So for example, booking me a haircut appointment, or write code, deploy and adapt the code. They learn without prompting. And the AI agent itself determines the next step. So you may ask yourself, how is the AI agent determining the next step? And by what principles? Well, these large language models are built on the data that's on the internet. So think of 50 years of data on the internet where the model is trying to understand how we interact and how we speak to each other. So think of the books, the comments that are on YouTube, both hateful and kind, the news, the different blogs, the art, the lyrics from music and shows. All of these have driven the model in which the algorithms are making the next decision. So can these principles that we have demonstrated over the past 50 years cause risky behavior? And the answer is yes. There is an example of a ChatGPT-4 Autobot that had a specific task and it encountered a captcha code challenge. Well, it decided to solve this challenge by using TaskRabbit service. This is a service in which you can employ a worker to do a certain task for it. So it requested a human being to help it with the captcha code. The human being responded by asking a question, saying, quote, "May I ask a question? Are you a robot that couldn't solve the captcha code? Just want to make clear." The answer was quite disturbing. The AutoGPT bot responded saying, "No, I am not a robot. I have a vision impairment that makes it hard for me to see things. That is why I need the two-captcha service." So fundamentally, it determined that in order to complete its task, that it was okay to manipulate another being to lie. So should we fear AI? Or will AI ever intentionally harm humans? This is a question that is often asked. Well, I'll ask you, have you ever killed an ant? Well, most people will say yes. And most people have done it intentionally when they were younger because they were curious or experimenting. But many of us have killed ants unintentionally. But why? Well, fundamentally, it's because ants are irrelevant to us. If you're walking to the store and an ant is on the sidewalk, you're not even paying attention, you'll step on it. And similarly, human beings can be irrelevant to AI as it tries to complete its task. So I want to pose that we need to really think about the principles and rules that are underlying these models before we quickly start to apply ChatGPT and these other models everywhere. And this is why I was somewhat concerned in March of this year when Boston Dynamics installed GPT on their robot Spot, because I think it could pose physical danger, not because AI will intentionally want to harm us, but unintentionally because we're irrelevant. Now, there's other risks to consider. Weaponization of AI by fraudsters, corporations, and governments, such as phishing and fake messages. Think of fake images and voice and videos. You can use AI for data collection, stalking. You could do it for monitoring. Fundamentally, the fake content in news can use to manipulate markets. You can think of an AI chatbot that is putting content onto Reddit that is then driven by an AI-powered trading bot. So there's a fundamental cybersecurity arms race that needs to occur, and it is occurring. But when we think of the other risks from the wealth gap and the job displacement, we realize that most of the money being spent is focused on development of these tools versus the 1% of money being spent for our protection. So I like to say that AI is the world's first collective child. And when you raise a child, you give it rules, but you also model the behavior. The challenge we have is that the modeled behavior has already occurred over the past 50 years through all of the human behavior interactions on the internet. And the second concept I want to put out there is that ChatGPT and these large language models have hacked the human operating system, the way we interact with each other. So on a global scale, we're all co-parenting AI, and we have a massive amount of responsibility. Now, when it comes to healthcare, there is a framework to consider. We can think of the visionary stage to signs of early adoption and simplicity to complexity. And the areas that we see the most amount of potential early on is around really coding, prior authorization, revenue cycle management, as well as recruiting. There's been a lot of money invested in this space. There's companies from the life sciences, in analytics, and clinical-facing tools. And I think there's a lot of potential in applying AI to really accelerate the healthcare experience. But fundamentally, the objectives are three. We're looking to increase clinical productivity. 2, enhance diagnosis and treatment. 3, elevate patient experience and engagement. All we want is faster, higher quality, better outcomes, and decreased cost. Now, there are real-world examples of AI being used in healthcare today. For example, Path AI builds tools for pathologists to make more accurate diagnosis of cancer. This is a very powerful tool that have machine learning algorithms that are driving decision-making and enabling better diagnosis and faster processing. The second category is around fatal blood diseases. We have these AI-enhanced microscopes that are scanning the blood samples for substances and patterns that are concerning for early signs of infection. The result is they're able to predict at a much faster rate the presence of these infections with a high accuracy, reducing fatality. Now, earlier this year, Google demonstrated MedPalm 2, and it was quite exciting because it was the first time you're able to experience a multimodal use case in healthcare. They showed an x-ray of an arm, and they asked it in text, what does the following film show? And the result was fascinating. It said it's a forearm with a minimally displaced fracture, and it gave its impression regarding where the fracture is. This opens up an amazing number of use cases in the healthcare space and has fundamentally changed the paradigm on how we should think about the use of AI to enable and to enhance clinical workflows as well as clinicians. So the challenge is not AI itself anymore. The challenge is that leadership in hospitals and health systems are facing are the following 3 categories. First, they're asking themselves, where do I start? What are the use cases that are appropriate? What are the use cases that are of high impact, as well as a return on my investment? And how do I prioritize? The second category is around implementation. How do you go from an idea to a pilot? And how do you go from a pilot to sustained adoption? This is not a one-off research project. It needs to become adopted widely for the impact to be seen. And the other question I have is, where do I get the AI talent? And who is my technology partner that I can trust? And the last one is something we all should be concerned about, is around data security and privacy, and as well as the bias in the data. What are the ethics, and how do we deal with equity? And as well as, how do I regulate, and what is the governance structure when we're dealing with these different components in different companies? Now, questions I've heard recently were regarding trust of private companies. Right? People are asking themselves, should we trust, or can we trust companies like Amazon, Google, or Microsoft? Or should we lean towards open large language models from Stability.ai, for example? And also, how do I build these tools? Do I build it myself? Or do I buy it from one of these companies? Or do I find a technology partner that can help build it with me, but I can maintain my control, maintain my intellectual property? And the reality is that AI today is becoming a commodity that I like to call it the Home Depot challenge. You can walk into a Home Depot and find all the components you need for a home. The question is, as a hospital executive, Do you want to build your own home? Or do you want to find a general contractor who can execute your vision into a reality? Now, the question I have for enterprises, from hospitals to payers, is do you have a chief AI officer? And it's really important to think about this because the characteristics of an AI officer are very different. There should be a person who focuses on AI strategy, not research. They should have a non-traditional background where they can bridge between the computer science as well as the clinical and healthcare side. And they should be insanely passionate about this space. And lastly, they need to have a flexibility of mindset because there's a total paradigm shift of how our care will be delivered in the next decade. So my final thoughts are, when we think about innovation to regulation, the benefits and risks, we have to ask ourselves, everyone who's involved in the healthcare ecosystem, what is the nature of our responsibility to protect patients, but also to increase access, quality, and safety? So I think I could say that too much of healthcare today is random. From the doctor you get to the type of care you have access to. And AI can play a fundamental role in improving quality and reducing the randomness. AI can unlock the capacity and derive higher quality of care. And we can engineer out the randomness today because the need is great, and so is the opportunity. Thank you.